today's class on chemical bonding. Now, this is also called chemical combination, okay? So what is this chemical bonding? Chemical bonding is simply an interaction between what? Atoms of what? Elements. Using what? Electrons. In order to attain what? A stable duplet or octet what? Configuration. The main aim of chemical bonding is so that elements or atoms of elements will come together and attain a stable octet or duplet configuration. That is the essence. So when we say duplet configuration or octet configuration, we are making a reference to what? The group 8 element, just like the noble gases, okay? Like already, the reason why group 8 elements do not jump into reaction at room temperature is because they are already stable at that condition. So you need an extra for you to force them. For example, for you to force argon to react, you must exceed that. You must catalyze the reaction by adding so many things that can initiate the reaction. But normally, the argon or group 8 elements do not like reaction. Why? Because their outermost shell is already what? Filled or stable, either duplet or octet configuration. So when we say octet configuration, we mean 8 electrons in the outermost shell, or 2 electrons for duplet configuration, 2 electrons. So that is the main aim why elements undergo bonding. So today, the first bonding we are going to look at is ionic bond. Ionic bonding. Now, most of us must have heard about this, but while some might not have heard about it, ionic bonding is also called electrovalent. Ionic bonding is also called electrovalent bonding. Now, what is this ionic bonding? Remember I said that these bondings are a kind of interaction between atoms of what? Molecules. Okay? Using their what? Electrons to bond. Now, when we say ionic bonding, we are simply saying that what? This is a type of bonding that involves, normally, this bonding involves metals and what? Non-metals. Generally, it involves metals and non-metals. Now, in this type of bonding, there is transfer of electrons, usually from this guy. This guy transfers electrons to this guy so that they can attain what? A stable configuration. Now, the electrons that they are transferring and accepting individually is just the valence electron. When we say valence electron is that electron that resides at the outermost shell of that atom. For example, watch. If I have sodium is a metal, right? What is the atomic number? This is 11. The outermost electron is what? 1, if you arrange the electrons in shell. Okay? So the outermost electron is 1. And let's assume that we have chlorine. Configuration is 287. Atomic number 17. The outermost electron is that electron that is revolving in the outermost shell. That electron, that is where the highest energy is going to be. So the bonding will take place between these two. Okay? So there will be a transfer of electron to this guy, because the moment this electron is transferred to this guy, this outermost shell becomes octet. Why this outermost shell becomes what? Also what? Octet. So immediately they bond. The new configuration or the new shell you will see is that sodium will become 2,8. While chlorine will become what? 2,8,8. At this point, they have bonded. Okay? So this is like writing an equation saying that sodium plus chlorine will give you sodium chloride. So the interaction existing between this and this will create a bond that will be holding these two together, and that bond holding them together is what we call an electrovalent bond or ionic bond. Now, this ionic bond is important because the moment this ionic bond is formed, energy is released. Okay? The moment the ionic bond is formed between a metal and a non-metal, an energy is released, and we call that energy lattice energy. So now this brings us to what we call lattice energy. You can be asked, what is lattice energy? A lattice energy is an energy released when an ionic bond is formed. Okay, that moment when the cation and the anion from the ions trying to form the ionic bond, when they interact, they release that energy. Now, the greater the energy released, the greater that amount of energy released, the more stable that bond is going to be. Okay, so lattice energy is simply the energy released when an ionic bond is formed, and the greater the lattice energy, the more stable the compound is, or the more stable the bond is in that compound. So take note of these things we are saying, because they can ask you in exam, what is lattice energy, or what happened, how can you relate lattice energy to ionic what? Bonding. Alright, so this is an example. There are more examples you can give here, but when you check the material, you see more examples, even energy diagrams. You can use energy diagrams to represent these things, but go to the past question, to the app, and check more on the what, on the examples given. But this is just the basics of ionic what? Bonding. Okay, now the properties of ionic bondings include, one is that they have high melting and boiling point, and you can attest to the fact because they interact, the electrostatic force of attraction holding those two cations and holding the cation. Remember that ionic bond is formed between a cation and an anion, right? When the metal donates electron, it forms a cation, right? When the non-metal accepts electron, it forms an anion. Now, the attractive force, or the force of attraction holding those two ions in that crystal or whatever where they are, is what we call the ionic bond. So this force of attraction is very, very high. Like I've told you, the more the lattice energy, the greater the force of attraction, the more stable the bond is. And now, due to this high force of attraction, it will be difficult for them to melt or boil. So the boiling and melting point is always high. Okay? Number two is that they are soluble in water. Why are they soluble in water? Ionic compounds are polar. Okay? Ionic compounds are polar in nature. So polar substance will dissolve in a polar solvent. So water is a polar solvent, so they are soluble in water, they can dissolve in water. That's number two property. The third one is that they can conduct electricity. Why can they conduct electricity? Because they form ions. Remember that the moment an ion is formed, any substance that have the ability to form ions have a tendency of conducting what? Electricity. Okay, so these are the few properties. Also, they are brittle. So these are the few properties of ionic compounds that you need to understand, coupled with the fact that we have been able to understand how they are being formed, where they exist, and the energy produced the moment this bond is formed. Okay, so these are the few things you need to know about ionic bonding. So the next type of bonding is covalent bonding. Okay, so this covalent bonding is simply a kind of bond formed when two participating atoms are sharing their what? Electrons. Okay, so remember the difference between covalent and ionic is that for ionic there is transfer of electrons, usually from a metal to a non-metal. So there is a transfer, they are not sharing. So that transfer of electron in ionic is what gave rise to what? Ionic bond. But for covalent bonding, the two atoms, let's say we have atom X and Y trying to bond. Remember the essence of bonding. The essence of bonding is to attain a stable condition, or octet or duplet structure. So between, let's say we have an atom X and Y trying to combine. The difference between this and ionic is that for this, the atoms are sharing, they are sharing what? Electrons. Okay? So this one is coming with one, this is coming with one. Unlike for ionic, that the other one does not need to come with anything, there's just transfer of electrons. So for this, the sharing of electrons between two participating atoms, let's say to form XY, let's say I want to form XY, is what we call ionic bond. Sorry, covalent bonding. Covalent bonding. So now, this covalent bonding can be divided into two types. We have the ordinary covalent bonding and the dative or coordinate covalent bonding. Now, this ordinary covalent bonding consists of also single, double, or triple covalent bonding. Now, we just said that for covalent bonding, there is sharing of electrons. The electrons that are being shared are known as the valence electrons. That is the same electrons that are in the outermost shell. Now, the particular electrons that are used for this bonding in covalent bonding are called shared pair. They are called shared pair. While those valence electrons that are not used for bonding are called lone pair. So the difference between shared pair and lone pair is that the shared pair are used for bonding. They are usually in this form, in this line form. Okay? It can be in double bond or triple bond. While the lone pair are usually as what? They come as dots. Okay? You can circle it like this. They come as dot. 2 electrons, meaning that these ones were not used for what? Bonding. So, how do we know the lone pairs and the shared pair? How do we know which one is shared pair, which one is lone pair? Let's look at some examples to explain this. But before I explain this, I will quickly show you the difference between single, double, and triple covalent bond. The sharing of 2 electrons between 2 atoms, right, to form a single bond. For double bond is sharing of 4 electrons between 2 atoms to form a double bond. While the last one, which is triple bond, is the sharing of what? 6 electrons. Example, if I have hydrogen, okay, each of these hydrogen has 1 electron, right? Each of these hydrogen has 1 electron. And if I'm to draw the shell, I have something like this, right? So this, before bonding, you have this that have just 1 electron. So the moment they bond, they will be sharing these 2 electrons to have what we call a duplet configuration, which give rise to this bond called covalent, right? So if you combine this with this, you have something like this, which shows that the bonding existing between these two here is what? A covalent bond. And because it is just 2 electrons to give rise to a bond contains 2 electrons. So the covalent bonding here is a single covalent bond. A single covalent. Why? Because I only need 2 electrons to form this bond. So the next one I will do now is for double covalent bond. Example, I will use oxygen, for example. Oxygen, for example. Now, oxygen exists in a molecular form like this, right? And we know that each oxygen is 8, right? Plus another oxygen, which is 8. So, how do we do this? Remember that the outermost shell of this oxygen, the outermost shell, is going to have 6 electrons. 1, 2, 3, 4, 5, 6. Right? Plus the outermost shell of the second one, we have also 6 electrons. 6 electrons at the outermost shell. Remember that the innermost shell, remember that each oxygen, how is it 6? Why is it 6? Oxygen is what? 2, 6 for each. If you arrange it in shell, 2, 6 for each. If you arrange it in shell. So the innermost electron is not needed because this is not the one taking place in bonding. What is bonding is the valence electron. This one inside here that contains these 2, which is this one, they don't take part in bonding. So there's no need talking about it because they're already stable, they are duplets. But these ones that are 6 outside, they need to become what? Octets. So at the end of the day, you can have something like this, right? You can have oxygen bonded to another oxygen with a double bond. So what happens here is simple. This guy brings 2 of the electron, this one brings 2 of the electron. So we have something like this. Having 1, 2, 3, 4. What happened? This one brought this one brought this. The 2 of them combined. So the bonding existing here, remember every other electron here remains the same. 1, 2, 1, 2, 1, 2, 1, 2. So if you notice what is happening here now, these 4 electrons is being shared by these 2 atoms, right? So if you count 2, 4, 6, 8, octet. 2, 4, 6, 8, octet. So these 2 two elements together are stable, giving rise to a stable compound. So the sharing of electrons between these two participating atoms gave rise to what? A double covalent bond. Okay, so this is a good example showing a double covalent bond. So take it note that in a double covalent bond, 2 electrons are needed from each of the participating atoms. One from here, one from here, one from here, one from here to form this. So whenever they ask you how many electrons are in a bond contains 2 electrons. So you can figure out how many electrons should be in 2 or 3 bonds, as the case may be. So this is a good example to explain the double covalent bonding. Take note. Let me now link it to the lone pair and the shared pair. These electrons that are now used for bonding is what we call shared pair. So this guy has 2 shared pair and 4 lone pairs. These lone pairs, these ones are not used for bonding. Even though they are valence electrons, they are not used for bonding. So they are called what? Lone pair. While the ones that are used for bonding are called shared pair. Now, the last type of ordinary covalent bonding is triple covalent. It's very easy, just like the double. Example is, let's use nitrogen molecule. Okay, nitrogen molecule, remember that each nitrogen contains 7 electrons. Bonding involves electrons, interaction with what? Electrons. So we will talk about electrons plus another nitrogen having 7 electrons, right? So at the end of the day, when the two combine, they will form a triple bonded nitrogen. Okay, so let's show example with the diagrams, right? So example, look at this. From this nitrogen, the outermost electron, remember that the arrangement is 2, 5. The outermost electron will contain 1, 2, 3, 4, 5, right? Plus another one will contain the same thing, 2, 2, and 1. Now, the moment these two combines, for them to attain an octet structure, they will be sharing 3 electrons. So what are we going to have here? We'll have each one coming together to form 1, 2, 3, 4, 5, 6. 3 will come from here, 3 will come from here. Left with what? Lone pairs that can be anywhere. You can put them here, you can put them here. Okay? So this one that are being shared here are the shared pair. And if 2 electrons equals 1 bond, then 6 electrons will equal 3 bonds. So this is the covalent solid formed. This is a covalent solid, a covalent compound that is formed. Okay? So what I have here is 2, 5. So this is an example showing the sharing of electrons, okay, involving what? 2 atoms of nitrogen to give rise to what? A nitrogen molecule which is more stable at this state. The next type of bonding you have to know about is the dative bonding. This dative bonding is also called coordinate. It's also called coordinate bonding. Okay? So what's the difference between this coordinate bonding and the ordinary covalent bonding that we know? The difference is that in the coordinate bonding, one of the participating atoms will not contribute anything in the sharing. Okay, there will be sharing, quite alright. There will be a sharing of electrons between the 2 atoms, but the person that will contribute to that sharing is just one person. Okay, that's the difference. And most of the times, what the person contributes is the lone pair of electron. The lone pair of electron. Now, some students will mistake coordinate with ionic. Ionic bonding is there is no sharing, it's transfer, and there is formation of ions in ionic bonding. But in covalent bonding, the ions are not being formed. Okay, what is happening there is still a sharing formula, but in that sharing, one of the participating atoms is contributing the 2 electrons or the 4 electrons or the 6 electrons that are used for the bonding. That's the difference. So example is ammonia. If I use ammonia for example, ammonia can combine with a proton or hydrogen ion. Take note, this proton, the positive charge means that it has lost the electron it has, meaning that it does not have any electron, right? Now, ammonia, being a Lewis base, has lone pairs, right? Has lone pairs, one lone pair. Ammonia has one lone pair. Now somebody will ask, how does this lone pair come into existence? Remember that nitrogen has atomic number 7, so it has 5 electrons in the outermost shell. So out of these 5, it has used 1, 2, 3 to bond the covalent bond. This is like the covalent bond, right? Now the remaining 2 that is in this 5 is what is here as lone pair. So this one can easily bond with this guy because this guy now is not coming with any electron, it is coming empty. So he can coordinate this guy into this place and they will share the electrons. So when you combine it with this, what you will definitely have is a nitrogen that will now be connected to 4 hydrogens. Now take note, this one is as a result of the bonding that happened here. Okay? So, and the moment you do that, you can close this bracket and then put that plus sign. The plus sign you have here, you put it here. So what will be formed when ammonia combined with hydrogen is ammonium ion. Ammonium ion. So this will form a coordination compound, which is the ammonium ion. So what has happened here is a coordinate bond. There is a sharing, yes, but the sharing is done by the 2 atoms, but one of the atoms contributed the what? Only the what? The 2 electrons used for what? Bonding.